Okay, students, so today we have to explain the next exercises. Basically, we have three exercises today, three small exercises to explain. Exercise 2, 1 point perspective, and 2 point perspective, and isometric drawing. Okay, we will explain the basics of it, the very basics, using our cubes. Let me just take a cube. Because we are dealing with cubes, so we will explain using this object. Now, before we start to get into the details of here, now our class is Introduction to 3D Drawing, 3D. So let us talk a little bit about the difference between 2D and 3D and understand really where we are, so that you can understand why we need to know about these methods or techniques, okay? So now here I put a few basic shapes. What is this? A circle, a triangle, a square. Now these shapes, from what they look like, they're 2D, 2D. It means they have length and height. Okay, length and height, all of them. They're flat objects, two-dimensional, and drawn on a flat two-dimensional surface. They're two-dimensional, okay? Now, when we have an object such as this, okay, what does this look like? A cube, okay? So this is a 3D or 2D. Now, you might say it's 3D, but this one is not really 3D. It is an illusion of 3D. Why it's an illusion? Why it's an illusion? Because I still draw it on a flat two-dimensional surface, but it somehow looks 3D, okay? But it's not really a 3D object. A real three-dimensional object is this, okay? This is a real cube, a 3D, and we will not call it shape. These are shapes, these are forms, okay? So this is a three-dimensional form. This is an illusion of a 3D. Now, you as designers, you need to be able to know techniques of how to create illusion of 3D on a flat surface, on a paper. So that's why we need to know about these techniques, okay? So these are techniques to make this possible for us, okay? So that we can draw things that appear 3D. So, now each of these methods, I would say techniques rather, have its specific way. So each one is different, and each one is used for different purposes. We will see when I explain what I mean. So depending on what you are drawing, sometimes you need to select this method. Sometimes you need this one, sometimes this one, okay? So we will explain each one of them and see the difference. Basically, what do these methods, in general, all of them have in common? Okay? Except this one. So the 1 point perspective and 2 point perspective I'm talking about. We have something called vanishing points. We have a horizon line and vanishing points. What does it mean? Now, first of all, the horizon line is always my eye level line. Okay, where is my eyes? Now, if I'm short, my horizon will be here, okay, from what I'm seeing. If the horizon line is always parallel to the ground line, okay, the ground where I'm standing, so it's parallel. Now, if I look like this, the horizon will look also tilted, but you never draw a tilted horizon. You always draw it straight, parallel to the ground, okay, in your drawings, I mean, okay. Now, these methods show how an object, let's say this object, start to appear smaller and smaller and smaller as it goes far away from us. So if I'm standing here and this goes towards the horizon over there, the more it goes far away, the more smaller it will look, okay? So this is basically techniques of how to draw this correctly. How an object appears smaller and smaller as it goes further away towards the horizon. And for this, we need a horizon line and we need a vanishing point. Vanishing point, that means all the lines of the object will go towards this point, converge towards this point, and then at some point disappear. Totally, we will not be able to see it. So, in one-point perspective, I will start with it. Now, each of these techniques starts in a different way. The one-point perspective, let's compare one-point and two-point perspective. One-point perspective, we always start the drawing with a face. What is a face? Like this object have a face. This is face. This is edge, okay? And in one-point perspective, if I want to draw this in one-point perspective, I must start with the face. I cannot start with edge. If I'm drawing in two-point perspective, always I must start with my drawing with an edge and then continue. Now we will see in practice how this will work. In isometric, later I will explain about this. This is a little bit different. So, 1 point starts with face, 2 point starts with edge. Now, because we are dealing with with cubes right now, I will explain on a cube. But this does not have to be a cube. It can be a rectangular object. This is also a face. Okay, so if I draw like this face, for example, this is also a face. Okay, but it's a long one. But we are dealing with cubes. That's why I'm focusing now on the cube. Okay. So let's first of all see how this works, the drawing in one-point perspective, and from then on we can explain more if needed. So one-point perspective, we have what? A horizon line, we said. Let me draw a horizon line. So parallel to the ground, okay? And we will put 1 point on it. One vanishing point. Where I put it, it's up to me. So where do I want the objects to converge, basically? So is it going like this, or is it going like that? Okay. So it depends where I want this to happen. So if I select it somewhere here for now, so this is VP, vanishing point. Okay. These abbreviations, you need to start to know them because we will use them all the time. This is one vanishing point. And now we want to draw what? Some cubes. So we have to start with faces. Okay? So let me draw a few faces here. Let's put one here. Now, we have all this space around the horizon line, around the vanishing point, where we can draw cubes, okay? But, if we draw it above or below, that matters. So, if my horizon is here, and I draw this cube below the horizon, it will look in a certain way. If I draw it here, it will look in another way. So here, for example, I see the upper surfaces. Here, I will see the lower surfaces. I will not see the upper surface, okay? So it depends where you put it in this space. So we start with faces. The size of the face, for now, we don't need a specific measurement. It can, you choose the size you want, suitable for the paper, okay? So small, bigger ones, you can draw several types, okay? Just to experiment with the technique. Okay, so now, what will happen? So we started with a face. We have now these here, edges that need to converge towards the vanishing point. So, from each of these corners, we will take lines towards what? The vanishing point. Now, right now, we are drawing, I would say, freehand in a way that we don't have specific measurements. So, I need to now decide, because we are supposed to be drawing a cube, so something that looks like a cube. I need to decide where is the end going to be. Like, should I put it here, for example, this line, or here, or here? Now, if I put it too far away here, this object will look, so if I put it here, for example, it will start looking like a long object, okay? So, it's not that it's wrong, but we are supposed to be drawing a cube, okay? So, this is wrong for our exercise. So, if I put it shorter here, for this size and this space, it may look okay, okay? Now, this will be parallel to this because this is a cube, okay? If I was drawing a triangular shape, it will be totally different. And this line must be parallel to this, because this is how a cube is, okay? Now, after I decide this space, if I'm happy with it, we can just close it off. The same thing we will do here. Okay? So I will decide where this line is going to be, and this line. And here the same. Now, we are not finished, okay? Now, when you look at this object, it is basically the cube. It's finished, completed. But I want you to draw also the hidden lines. What's the hidden line? Like when we see the cube, we see it really like that. But if you imagine it to be as a glass, okay, we will see also this line here inside, and we will see this line. So this you also need to draw. Now we already took this to the vanishing point. We need to put also a straight line down from here. Now notice I make it dashed, okay? If everything that is hidden inside, you make it dashed. Because if you make everything with a straight line, it will start getting confusing, okay? So which is the outer line, which is the inside line, okay? Just to differentiate. So this is a dashed line, and this line we already made it. I will just make it a little stronger. And this point with this point, it also to be connected, okay? Now the cube looks like a glass cube. We can see the internal hidden lines and the external visible lines, object lines. Now, these words that I'm using, object lines, hidden lines, this kind of stuff will keep repeating in design, okay? So you need to learn about them. Later I will explain a little more about them, but now we are just starting. Here we will do the same. We have this line, which is going to be parallel to here, touching this line, which we already made, and this corner with this corner. If your object drawing is perfect, it should basically touch. Now, if you draw these three lines and they don't touch in a point, it means there is something wrong with the drawing, okay? There is something off. Maybe your line is not parallel, maybe there is something wrong with it, so you need to repeat it. Okay. The same thing here. So here we have this here line, and we have this here line that needs to be parallel to the others and touch this line, and then this corner down to this corner to touch. So if you notice the placement of the cube, which surfaces do we see more? Like we can see this surface here because it's below the horizon, and then when it goes above the horizon, we don't see the upper surface, we see the lower surface. So, now we can draw more cubes in this area, then they will become smaller and smaller and smaller and smaller as they go towards this vanishing point, okay? Later when I explain about the homework, I will explain exactly how many you need to do and other details. So this is basically, for now, one point perspective with one vanishing point, okay? This is how you draw a simple cube using it. Now let's see the difference if you want to draw the same or similar cubes using two-point perspective. What will happen in this case? In two-point perspective, we have, again, so this is what did we say, a horizon line, HL. Okay? We have to draw another horizon line here. Now we need to put 2 points. Now be careful with putting the 2 points. Never put them close to each other. Why? Because where you put these points, you are only allowed to draw in this space. You see this space here? So if I put here, this can go endless up. So this is limitless, but the limit is here. So I can only draw cubes in this area or this area. Do you see? I cannot draw it here or here if my points are here. So don't limit your space. Don't limit. So you need to what? Put the points more farther apart. There is no rule how further apart. We will see also as I explain more. There is no rule. There is no specific like measurement. It depends on the paper size. It depends on the project. It depends on what you are going to draw here. Is it big? Is it small? Okay. So all of these things will affect. But in general rule, keep it further apart. The more the better. So if we put it here, for example, actually even more. Here and here. Okay. So this is now VP1 and this is VP2. Here we said the rule is what? We have to start with edge. So we will draw some edges. So let me draw one here, one up here. We can keep drawing, but the space is limited. So edges again, from here to here, what is the measurement? For now, we don't need to worry about it. Later, I will tell you, okay? For now, we don't. So now we started with edges. We need to draw 3 cubes. So we need to take each of these points to the vanishing points, but to each one of them. So from here, we will do like this. And then to take it again to the other vanishing point. The same we will do with this one. And with this. Now, you can draw each one separately. Like what I mean is, you can draw this fully and then move to the next one. And then I'm just drawing them all step by step together. Okay, so you can do it this way or that way. It depends. You know? Now, the same thing that we did here, we do here. We have to decide where this line is and where this line is. So we have an edge. Where is this line and where is this line going to be? So that it looks like a cube. Right now we are dealing with to make it look like the object. Later on we will learn about more accurate techniques that you can apply to actually have the correct measurement. Okay? So let me see. Now, very important rule when you draw something freehand is to consider the location of this edge. Let me make it clear, more clear. For example, we have this edge which is kind of closer to this point. It's closer in this, not closer up here, but closer in this direction. And we have that one that is closer to the other point. This one is somewhere here in the middle of the two, almost. So it depends where is the location, because this will affect from here to here how much, and from here to here how much. So if this edge is closer to this point, it means that this side will be shorter than this side. We will see more of this than this. It's like if you consider your eyes are in the middle here, okay, of the horizon line, and you move this object that way, this way. It doesn't matter where it is. It might be up here, but same. Do you move it this way or that way? So if my eyes are here and I move it that way, so slowly I will start seeing more and more of this face and less of the other face. Here in the middle I will see exactly the same from both sides. Here I will start seeing this one become more and more bigger and this smaller. It's an illusion. It's not the reality. The reality, they're all the same. Okay, but in the perspective, it will look that way. So, if this edge is closer to this point, that means this will be shorter. So I will put it here, and I will put this one a little longer. This space here, okay? This compared to this. And then, we have to decide for the next one as well. This one is closer to this point, so this one will be, this space will be shorter this time. And this will be the longer, from here to here, okay? Here, it's a little bit closer to this point, so this one will be a little shorter than this. Okay, now we try to continue and see. If it doesn't look like a cube, you can rub it out and repeat it, okay? Now we made these two lines. We have other points now that we need to connect. Connect to the vanishing points. So this we connect to the vanishing point. And look, this one we connect to this vanishing point. This one we connect to the other vanishing point. It's like the opposite, okay? This side there, this side here. And as we can already see, what we see here is the cube. So this one is basically completed, just left to do the hidden lines, the inside, okay, which we will do later. Now this one here, what to do with it? Again, this line is from this side, so we will connect it to that vanishing point. And this to this vanishing point. Again, the cube is ready. And we do the same with this one. This line to this vanishing point, and this line to this vanishing point. Okay. Now let's do the hidden lines, okay? These also have hidden lines. So what shall we do here? From each of these corners, so this corner we connect here, this corner we connect to that vanishing point. And where they intersect, so it's this point and this point, we need to also connect. So if they meet perfectly at a point, then you have done it, at least the lines are correct. Okay, what about this one? Okay. We have this corner that we need to connect over there. and this corner to this vanishing point. And then where they intersect with this point, it has to be a straight line down, straight, parallel to these lines, and it needs to intersect. Okay. So let me just delete this here so you don't get confused. So these here we will also remove. Okay. So these are the hidden 3 lines. Here, here, here. Here, here, and here. Now here, what will happen here? This point to this vanishing point, and this point to that vanishing point. Where they intersect with this corner, straight line down, and it's finished. Again, notice when the cube is above the horizon line, you can see the surface below, and when it goes down, you can see the surface above. But how much? So if my horizon is somewhere here, and I put this down, this surface, the more I put it down, the more bigger it will appear. And if I put it exactly on the horizon line, I will not see this surface or this surface. And when I put it up, I will start seeing slowly this surface, more and more and more bigger. So if we have, for example, a cube exactly on the horizon line, let's say here, for example, what will happen? Well, let's take to the vanishing points and see. So this will take it to the vanishing point, and here, and here, and here. Then we have to decide on the location of this and this. Now, again, it depends where is this located. Is it closer to this point, or is it closer to that point? If it's closer here, this will be shorter than this, and the opposite. If it's exactly in the middle, they will be equal, okay? So, where is it located? Oh, it's a little bit closer to this point. So this side must be a little shorter than this side, okay? And then, our cube is basically complete. But notice how we don't see the upper or the lower surface here. We don't see them. Now, the invisible lines, again, from this corner to this, from this corner to that vanishing point, from here again, here, and you will see where they will intersect, and there will be another line from the back. So, it depends where you locate your cube. It will look in different ways. So, now 1-point perspective and 2-point perspective is used for different things. Now, if I want to draw my object, let's say what in real life? For example, this room, this classroom. Let's say you are interior designer and you want to draw the tables here inside, the room, the windows over there. So where I'm standing now and I want to draw this room from like this. I want to draw all the tables like this. I will choose 1-point perspective and I will start with a face. The face is what? This here. Do you see here this face of the room? Basically that's where I'm standing and I'm drawing this room converging into the 1 point. But if I decide to draw it from an edge, I want to draw the room from here. Now, this is basically an edge, okay? So now I have to use 2-point perspective. This will go to one vanishing point, and this wall will go to the other vanishing point. So it depends on from where you want to draw the object. It depends what is asked of you as the exercise, or what you want to let us see, okay, and in which way. So this is correct, this is correct. It depends on your choice, okay, and what is needed. Okay, now what is this one? The isometric drawing. The isometric drawing is a little bit different than these two. Now, we will talk about this later on. It will become a little more clear. Now, it's the basic rule just of how to start the isometric drawing. Isometric drawing is not a perspective. It's not, it is put here as a perspective, but it is not. The 1 point and 2 point perspective, they're perspective drawing. This one looks like a perspective. When we draw it, it looks like a perspective, but it is not. This is a technical drawing. Accurate technical drawing always have measurement. Always. You cannot draw it without measurements, this, okay? And it is used for accurate depiction of the object. Like, for example, if I draw this in isometric drawing, in the drawing it will look a little bit like a perspective, but the measurements will be very accurate. So when I look at it, I know exactly, this is okay, this is a 10 centimeter cube, for example, okay? Or whatever object it is. So this is used for accurate drawings. What is the reason we need accurate drawings? This is if I'm drawing, for example, I have an idea, a design I'm making, and this is my idea, and I want to draw it on a paper so that someone else, when someone else looks at it, they know how to build it. So if I'm, for example, designing this table, and if I'm using 1 point or 2 point perspective, okay, it will look beautiful. But the one who looks at the drawing will not understand what is the measurement of this, what is the measurement of this. They will not know how to make it, how to cut the wood, for example, okay? The material. So the isometric is where accuracy comes, okay? It looks like a perspective, but it's not. It's very accurate drawing. So let's see the rules of how this works. Later you will also see that technical drawing, which is isometric drawing, and another type, which is orthographic drawing, in design always go hand in hand. So in the future, when you do many projects, you will be asked to do it in isometric and orthographic. Orthographic, sometimes called plan view, okay? So these two always go hand in hand when you design something real. And when you design something and you need to make a very accurate model out of it, or a real object, okay? So, isometric drawing, how does that start? Now, of course, just let me mention that whatever technique you're using, you still need to use your tools, okay? So, for example, you have a paper where you draw these, you still need to put the tape, okay, on the corners. You need to put the T-square, and with the T-square to be able to draw, for example, any straight lines you have, like this, for example, they're straight, to make sure that they are parallel to the paper. And then to use the other rulers when you have, for example, these lines to do. Be careful not to do it freehand and to do the ruler like this. One line will be like this, one line like this. No, you put the T-square, you put this line, and you draw straight, beautiful lines while the paper is fixed on the table, okay? With the isometric, for sure you need to do it, because otherwise it will be a disaster. So you have your paper, I put even here the tape, as you can see, the T-square you will put it, and you will need to use the 30-degree angle. Which is the 30 degree? This is the 30 degree. So the lines that you will draw will have to be at 30 degree. Now, because we are doing one cube now, it's very simple, but later when we draw the entire composition, the model, there will be a lot of 30-degree angles, okay? So you have to move this around, draw many lines, then go up, draw more lines, and all of them have to be perfectly at 30 degree. So the isometric starts with, okay, here is space dedicated for it. So here we will draw it. So we need to start with the isometric drawing. First to start, this time, we don't have horizon line. No horizon line, no vanishing points, okay? We start with the ground line, the ground, okay? So we draw a ground line. And this is called GL. Later we will keep using these lines, GL, the ground line, horizon line, so many types of lines, okay? But you need to get familiar with them. So the ground line, we draw first. Then, we have to draw, again, an edge. like this, okay? An edge. So in isometric drawing, you always have an edge also. You cannot draw it this way, okay? Now this edge, you need to know exactly the size of it. So if it's 10 centimeter, 5 centimeter, 2 centimeter, whatever, okay? So from here it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For example, let's make it 10 centimeter, okay? Okay, great. Now we need to draw using our t-square and 30-degree ruler. So imagine the t-square is here. We need to draw a what? A 30-degree line that goes from this point here. Then we flip the triangle and do it the same from the other side. Here. And so in isometric drawing, this is 30 degree. And this 30. There is another type where here is 45, here is 45, okay? But we will not use it. This is better now, okay? So focus on this. Always 30, 30. From here, this is the first edge with a specific measurement. Now, we need to draw what? The other sides of the cube. The difference between this and these methods is that the lines are always at 30 degree parallel to the other lines. So if I want to draw this line now, and this line, so if I put here an imaginary line, this has to be 30, this has to be 30. Now you don't have to put this line, because when you use your t-square and the ruler, you just move it up, move it down, and connect, okay? But these must be parallel. They don't meet at a what? Vanishing point. They don't meet at a vanishing point. They'll stay parallel forever. So if you have one cube or 10 or 20 cubes, all of them follow the same rule. The lines are parallel. Now, where shall we stop? Here and here. Because it's a cube, 10 centimeters. So from here I measure 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is where we stop. And from here we do the same and stop in the same place. You can find the location from here. You don't have to keep measuring from this point, just a straight line. It will touch this corner and you will know its location. Okay? And then what's the next? So this is 10, this is 10, this is 10, because that's what I asked you to do, okay? Now, we have still this line and this line to do. So this line here has to be, again, at a 30 degree parallel to this line. And this line has to be parallel with this line and this line, parallel, okay? So at 30 degree. Now you need to be very careful. If you don't use the rulers, and you will get it wrong. Okay? So if I measure this, must be 10. Now if I measure this, how much must be 10 again? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this must be 10, 10, 10, 10, 10, 10, everywhere 10, because it's a cube. Now if I was drawing another object with different measurements, like this table for example, this is not a cube. This is long, this is short. Then my drawing will also be like this, okay? So this is isometric drawing of a cube. Now, there is no need to draw 2 or 3 or 4 cubes, because all of them will look the same. Because it's a 10 centimeter cube, so what to do with it? You know, like if you draw another one, it will be the same. So you draw only one, okay? And it's finished. So looking at this, I know exactly. This is a 10 by 10 by 10 centimeter cube. If I want to make it, it's very clear. Now, talking about this method, we need to mention something else. Do you see here it says scale? What is scale? We need to understand scale also for to draw in isometric correct. So scale is, like for example, this is now scale 1 to 1. This is what I did, is scale 1 to 1. It means I did it exactly on the actual measurement of the real object. So this is 10, and my drawing is 10. But sometimes you have to draw a very big object on a small paper. Let's say your model, this have a lot of cubes, and you have to draw it on a small A3 paper. There is no space to draw it scale 1 to 1. That means the real here. No scale, no space. So we have to reduce its size, but according a scale. So let's say what will happen if we reduce the size of this to scale 1 to 2. What will happen to our drawing? That means the real measurement divided by 2. So on here, this will not be 10 centimeter if we follow this scale. It will be 5 centimeter. 10 divided by 2 equals 5. Okay? So this will be 5, 5, 5, 5, 5. And it will be scale 1 to 2. What if we use scale 1 to 5? So we have a really big object. We need to draw it on a small paper. We need to increase the scale. So 1 to 5 means 10 divided by 5 equals what? 2. So on the paper, this will be 2 centimeter only. 2 by 2 by 2 by 2 by 2. If it's a cube, okay? So now we can have more and more. We can have 1 to 10, 1 to 15 scale, 1 to 100, 1 to 1000. Now if you want to draw the Yarmouk University, all of it, from as a plan view, for example, or as an isometric, then you need to scale it down into all of Yarmouk University into this paper. You need to use a scale. Maybe 1 to 1000 or 10,000, I don't know, okay? So the bigger it becomes, the scale must be also increased so that it fits into the paper. But it is still 100% correct. So if I see, okay, the student used scale 1 to 2, and this is here 5 by 5 by 5 centimeter, I know that in reality, I need to build a 10 by 10 centimeter cube. So 5 times 2 is 10. So this is the real object. Okay? So when you do isometric drawing, you must be very precise, and you must always state the scale. What scale did you use for it? Because I don't know otherwise. What is the real size? So this is how you start an isometric drawing with a simple cube. Later we will see how it works with the entire model. You will draw it in isometric later on. And also what is orthographic, we will talk about how the two connect. You will see all of these things later. Now, just understand and remember the rules. So, what's the difference between this and this? What's the difference between this method and these methods, okay? And how to start it. Like, don't forget this has to be 30 degrees. Don't forget you have to have your measurements. So these things you must learn now, okay? To be able to continue next time in a correct way. Now, a few other things I want to mention that you need to be very careful about before I mention the homework. I will go back to the perspective, to the two-point perspective method. Be very careful here. Sometimes you have, okay, let's say this paper. On this paper, you will draw the horizon line, and you will draw the 2 points, the vanishing points, which is great. But these 2 points on the horizon line do not always have to be on the paper. Like I can draw a long horizon line that go up to here, and here is my point. And use this point to draw the rest. Sometimes you must do that. Why? Because if we have let me delete here something to show you. So let me delete these cubes and draw something to show you what will happen in certain situations. So, in the first time we put the points here. Let's say the paper, it's inside the paper, okay? What if I put, forget here that the points are here now. We will put them really close here, one here and one here, okay? VP1, VP2. Now these 2 points, we have this space here where we can draw inside. Great. Now, for this space, if I draw a cube that is, for example, this small, and I take it to the vanishing points, like we did before, then decide where these sides are, take this to the vanishing point and this to the vanishing point. No problem. It looks okay. But if I want, for this space, if I want to draw a bigger cube, let's say this size, okay? Now, there is no specific measurements that you can, that I can tell you this is the rule. But from the drawing, you will see if, oh, okay, my points are too close or too far away. Now, with these points, this size cube looks fine. But if I want to draw a really big cube, and I will apply the same rules. I will take to the vanishing points, decide, okay, let me delete it here so you can see. So we take it to the vanishing points, and we decide where this side is going to be and this side, and we take it again to the vanishing points. Now, I applied the rules correctly. This is correct, but it is what? An exaggerated exaggerated perspective. Exaggerated. It means it's, look at this here, angle, it's very sharp. It doesn't, it looks like there is something wrong with it. Now, if this was a building, okay, a big, long building, maybe okay, but for a small cube, it looks something is wrong with it, okay? So this is exaggerated perspective, and it is considered wrong in the drawing, especially in design, okay? So when this happens, like this corner, it's very sharp, and even this corner, it means that the object is too big for this vanishing points. That means you need to take the vanishing points and put them further apart. So if you want to do this size, okay, you need to put them more far away, okay, and then do it. Now, if you do it now, okay, it will be a totally different object. It will look much better, and it will look more realistic. So if you draw something too big and these points too close to each other, it will become exaggerated and not correct. So now, when you have this type of paper, this size, and you have to draw something on it, sometimes it is a little big, so you don't have enough space. So you need, when you draw the horizon line, you need to put the VP1 here maybe, and the VP2 here. And when this paper is fixed with tape on the table, it shouldn't move, and you can use your ruler, the long one, to connect the points and draw the object correctly. So what I mean is, if these points are not on the paper, it's not a mistake. I don't care about them. What I care about that you connect correctly, and the final object that results looks the way it should look. Okay? Now, so be careful with this, because I explain it and some students still make this mistake. Now, we have to be careful about certain things. The way you draw your drawing, okay? The way you draw it. The lines, you need to be very careful. Different lines must have different line weights. Now, In reality, in design, later, you will see that there is many types of lines, many line weights, meaning the thickness of them, and so on. For our purpose, we are still in the beginning. We will use 3 different types: heavy, medium, and light. If you manage to do that, your work will look perfect. So, what do I mean with that? So, for example, the heavy line, if you sit over there, you should be able to see it. Maybe everyone sees the border, and here some of the object. The medium line is a little bit lighter, less thick. So lighter, for example, we don't need to see what the construction lines, these lines, heavy. We don't need to see them, because if you make the construction lines, these are called construction lines, these, okay? If you make these very heavy, imagine in the future when you have, let's say, 100 cubes to do, for example, and all these lines on the paper, it will look so ugly. So we need to see the object. This is number 1. The construction lines, can you see them or you can't see them? They're very light, okay? So this is a medium. And we have the hidden lines, which are these. They have to be also a certain thickness so that they don't stand out more than the object lines. So we have basically we have on the paper, you will have a border line. You see border lines, which are these. They have to be heavy, visible, okay? The object lines are the outside lines of the object. They also have to be heavy so that it stands out from the paper, okay? The construction lines, any lines that you use to construct the object, should be light. The lighter, the better. So when I look at them from here, yes, I see them, but I don't want them dark and heavy and black, okay? And then we have what? Hidden lines. Leave these medium thickness. Not heavy like the object, and not as light as the construction lines, in between. So keep these 3 levels so that your drawing will be perfect. Another thing, the cleanliness, how clean it is. I don't want to see deleting, smudging. Be careful your hands to be clean, the rulers to be clean. If you draw something with a ruler, never smudge the ruler on the drawing like this too much. Pick it up, put it here, okay? Pick it up, put it, so that it doesn't create smudges. This paper has to stay white and perfect. Only these lines have to be seen. And remember, this must stay 90 degrees when you draw with it. Otherwise, the lines will also not look good. Great. Now, now from now on, because we will draw on A3 Fabriano, which is this size, which I mentioned before. Be careful of the A3 plus. I don't want to see that. Okay, A3 exactly, which is 2 times the A4. All of them will have the same border. Do you see any of these drawings? They have the border. The border is how much? 2 by 2 centimeter. So 2 centimeter from here, 2 centimeter from here. Not 1.5, not 1.8, 2. And all of the papers you can take at home, you can make all of them, you know, like many papers, so you don't have to draw the border each time. So you can do that all in one go. Border 2 centimeter by 2 centimeter. And heavy, the way it is here. Everything that we will draw will be inside this space. Now, please, for now, you will draw landscape, not like this, okay? Like this, for our exercise. Sometimes we need to draw like this in the future, but not now, okay? So landscape. So this will be like this, your homework, 3 sheets. What you need to do on these sheets? In first sheet, using 1-point perspective, okay? You need to draw at least 3 cubes inside. So, something like this. Where is the 1-point perspective? For example, okay? You can draw more, like this student. Okay? But not less than 3. So how many you draw, it's up to you, but the minimum is 3. And the size, as you can see, there are smaller, bigger sizes. That's up to you also. Now it's just to practice the drawing. Not worry about too much measuring. So, the next sheet, you will have 3 cubes in 2-point perspective, like this. Again, minimum of 3 cubes in 2-point perspective. So we need to see the horizon line, the construction, everything, but according to these rules. Okay? And then we have here 1 cube in isometric scale 1 to 1. Okay? So it should be at 10 by 10 by 10 centimeter cube. And on the drawing, it must be like this because it's scale 1 to 1. Okay? So it will look like this. Something like this, okay? So here, everything must be 10 centimeter, and you must show the degrees, you must show the ground line, everything according to the rules. And also don't forget to write here scale 1 to 1, because you need to get used to these things from now, okay? So this is your homework, 3 sheets that you need to complete. Now you need to complete them, of course, until next class they have to be ready, but I will not put marks on them. Marks I will put later, like for example you do these exercises, you do then exercise 5 and 6 and 7 and 8 for example, and then I will tell you bring them all together on this specific day. Then you have to bring them all, okay? Until that time you have opportunity to repeat if you have mistake or, you know. The only thing that I want for next class is this to be ready. On this I will put marks, okay? On the drawings, no. Okay? Any questions? If you have any questions, just think and ask me, please.